So yeah, this is, can you see this PPT? Hello? Hello?
Yes, sir.
Can you see this PPT?
Yes,
Yes,
sir.
sir.
All right.
Yes,
So yeah, this is the agenda today. This has a lot of mathematics, so I request everyone to have a pen and a pencil so that you can follow all these small mathematics. So this requires a lot of mathematics. I will teach you in a simple way. So make sure you have pen and pencil as well. All right. So what is the problem with this? You remember we did this algorithm with this. We did this program. This is the program number 9, the last program. Remember this? Hello.
yes, sir.
Yeah, we did do this, but the problem with this is this particular program requires only a fixed polygon, right? So if I have an unknown shape and if I ask you to fill, you definitely cannot fill it. So this algorithm addresses that issue. So this issue, right? You ready with the pen and the paper?
Yes, sir.
All right. So let's start. Now the aim is to fill, let's say, this kind of a polygon. So I request everyone to write this polygon because the coming slides doesn't show this exactly the way we are showing right now. So I have carefully earmarked all these edges. I mean edges as well as the row numbers and the column numbers. So I request you guys to write this diagram first, and I shall give you 3 minutes of time. And once we are done with this, we shall go with the mathematics.
Topic 20 minutes ಅಷ್ಟೇ ನಾನು 4 to 5 ಅಲ್ಲ 5 to 6 ಆಗಲ್ಲ.
Are you writing? Shankar class. So if you're done with this writing, let's start then. I'll give you 1 more minute time. You there, guys? Yeah, I'm seeing 98 guys. All right. So make sure you write this diagram because this is the initial diagram which will help us to fill inside this particular polygon. I want everyone to write this 0 to 13 and 0 to 11 here, and then this polygon. Shall we start? You guys done? Okay, I'll give another 10 seconds. Then we'll start. All right, let's start. So as you see, every edge has a starting point and an end point, right? For example, edge E1 has starting point at, can you tell me this coordinate? This is 2, 1, and edge 1 ends at 6, 1. So similarly, edge 6 starts at, this is what? This is 4, 13. This is edge 6 ends at This is perhaps 8, 10. So every edge has two points, start point and the end point. And we need to carefully go inside this very unstructured polygon, and we need to carefully fill this. Now, in order to fill this, there are some prerequisites. So that prerequisite starts from this. Now, let us take this edge. This is, I'm talking about the mathematics now. Let us take this edge now, an edge starting from 1, 2 to 9, 6. So you can carefully earmark this as x min, y min, and this as x max, y max, right? So the algorithm says you need to carefully take x min and only y max, and the third one, it's kind of a linked list. You know, a linked list has 3 data fields. The first field talks about x min, and the second field talks about y max, and the third field talks about 1 by m. If you ask me why 1 by m, well, if you consider y is equal to mx plus c, and x becomes y minus c perhaps, or b minus c by m, and the x at the next edge, that is y plus 1, is always substitute y instead of y plus 1, you will get y minus b by m plus the constant 1 by m. And that's the reason 1 by m comes here. So yeah, this is the mathematics, and I believe you're done with this. Take an edge. I'll summarize. Take an edge, any edge. It has x min, y min, x max, y max, and the bucket table. This is what we call as a bucket table. Bucket table has 3 fields: one x min, second y max, third 1 by m. So x min is 1 here, and y max, x max, y max is 6. And calculate m. What is m? y2 minus y1 by x2 minus x1, 6 minus 2 by 9 minus 1, that is 4 by 8, and apparently 1 by m will now become 8 by 4. So this is the initial mathematics that we need to do, and the algorithm says to repeat this for every scan line, which we shall do right now. All right, now consider this polygon which you have already written. So I have earmarked carefully as 0, x-axis is 0, 1, 2, 3, 11, and y-axis 0, 1, 2, 3 up to 13. And this is my polygon, and I need to fill inside this. This is the agenda today. All right, guys, I have only, as you know, the Zoom session is only for 45 minutes per session, and we are already done with some 10 to 15 minutes. So another 13 minutes, we should be able to finish this. All right. So please be with me. Don't get distracted. So consider this particular polygon. My class really starts now. All right. So this particular slide talks about the initial edges. You can see here this column 0, 1, 2, 3, where my mouse is pointing at 0, 1, 2, 3, 4, 5, 6 up to 13. This is called a scan row, scan line perhaps. So in the 0th scan line, can you tell me which edges I have in the 0th? In the 0th scan line, I have E10 and E9. So this is that E10 and E9. In the first scan row, that is in the first row, how many edges I have? I have E1, I have this E2, and this E11. Also, I have E10 and E9, but the point is E10 and E9 I have already written in scan 0 line. So that is the reason I'm not considering E10 and E9. Are you now understanding it? Can I get a yes or no?
Yes, sir.
Okay, I'll repeat. My actual class starts from this slide. This is 0, 1, 2, 3, 4, 5, 6. These are all scan rows. In the 0th scan row, I have E10 and E9 edge. In the first scan row, I have E2 here, E1 here, E11 here, E10 here, E9 here. So E10 and E9 I have already encountered in my previous row, that is 0. That is the reason I'm not writing E10 and E9. So moving on, there is this scan row called 2. In the scan row called 2, I have E2, E11, E10, E9. All have been encountered before itself. So that is the reason I'm writing empty here. E3, the edge number 3, that is the scan row 3, I have E2, E11, E10 and E9. All have been encountered before. That is the reason I'm writing empty. Similarly for 4, 5. So if you look at scan row 6th row, I have a new edge coming as E3 and E7 and E8 as well as E9. E9 has already been encountered. So the remaining new edges are in the 6th row. It is E3, E7 and E8. So that is what I am writing here. And go to 7th. This is 6. This is 7. I have a new edge E4 and E5. The old edge is E3 and E7, E8. E3, E7, E8 already been written in the 6th row. So in the 7th row, I have only E4 and E5. So 8th row, I do have E3, E4, E5, E7 and E8. All have been encountered before. That is the reason I'm writing empty here. 9th also same story. 10th one, if you look at this 10th one, I have a new edge called as E6. Other edges have already been encountered. That's the reason I'm not writing anything. Similar story for 11, 12, 13. So I believe this slide is done. This is the one. This is just an initial slide. No mathematics have been applied. This talks only about how exactly we can start the mathematics. All right. So shall I proceed, guys? Yes or no?
Yes, sir.
All right.
Yes, sir.
All right, good. So be proactive. Okay? I mean, whenever I ask you guys, please say yes or no in unison so that I can understand whether you understood this slide or not. So now the mathematics starts. So before, you should write the heading called before pre-processing, and that is before applying this particular. Now this is where your pen and paper comes. In your paper, you have already written this particular polygon with these edges. Now let us apply this particular mathematics, whatever I'm showing now, for all the edges. That is, please write this x min y max 1 by m for all the edges. We should write this x min y max and 1 by m for all these edges like this. Now let us start from E1. E1 in the sense edge 1. Edge 1, here. Edge 1, there is no edge at all. This is the E1, no edge at all, which is at starting at, this one. That is the row number 1, which has the starting point at, 2, 1 and 6, 1. Now, before we apply the mathematics in future, let us do this before pre-processing stuff. Now, edge E1, look here, edge E1 starts at 2, 1 and ends at 6, 1. So whenever you have a horizontal edge, make sure you don't apply this particular mathematics. So this mathematics applies not for horizontal edge. So that is the reason E1 doesn't have any x min y max 1 by m. So why, I will tell you later in a couple of minutes. So let us take edge E2. E2 starts at, you can consider this as the starting angle, starting point, 2, 1, and edge 2 ends at 0, 6. So if we consider that, what is x min? X min. So this is 2, 1, or this is 0, 6, 2, 1. So please write it x min, y min, x max, y max. So you will get to know that x min is 2 and y max is 6. And calculate m, that is y2 minus y1 by x2 minus x1. You will get it as minus 5 by 2. So 1 by m will now become the reciprocal of it. It is minus 2 by 5. So similarly for edge 3, edge 3 starts at this particular point, that is 0, 6. Edge 3 ends at 2, 12. So you can earmark this as x1, y1, x2, y2, and therefore you can write x min as 1 by 3. This one is 0, 6. This is 2, 12. This is, you can take it as 0, or you can take that 1 by 3 means nothing but 0.33 to be very accurate. So y max is 12 and 1 by m is 3 and 1 by m is 1 by 3. So like this you do this for all the remaining edges. So we have totally from E1 to E11, and this is how you'll get x min, y max, and 1 by m. This is all before pre-processing. Now let us apply the scanline filling algorithm. Now to apply scanline filling algorithm, there are some prerequisites. These are the prerequisites. I told you, you should not apply the mathematics for a horizontal edge. Like this, we have some rules. First rule is, look here, there is this particular point. See, there are two edges here. You can consider this as edge number 1 and this as edge number 2. There is this conjoint edge. So what we should do is we should take this one as x1, y1 to x2, y2, and again the same particular point as x1, y1, and for this guy x2, y2. So whenever you have a conjoint coordinate, make sure you count twice, one for each edge. And you can see here there is one more conjoint edge here. What we will do is we will separate this, and we will consider this particular point as 2 points. So how can you consider is, chop the lowest pixel and make sure you increment, you just chop it, and the next particular scan line will now become your this x1, y1. So I'll repeat, there are some rules to apply the mathematics. First rule is, whenever you have a conjoint edge, conjoint vertex, you count twice instead of counting once. And whenever you have an edge like this, a lower hemisphere and upper hemisphere, make sure you chop the lowest pixel, and to count only once. So the one edge will now become, one particular point will now become 2 points. And third one is, whenever you have a horizontal edge, you might as well delete it. You can ask me why. Well, there is no point in filling between this edge and this edge. That is, we know we should fill from this point to this point. So since we already know this, there is no mathematics. There is no need for any mathematics to help us. We'll understand this later in another 10 minutes or so. All right. So we delete that horizontal edge. The edge will become like this. And let us apply these prerequisites, 1, 2, and 3. These three prerequisites for this particular polygon. Now, if you look at this polygon, you can now see there is a horizontal edge called E1. So we should be deleting this. And there is a lower hemisphere E2 and upper hemisphere E3. So we should chop the lowest pixel and we should go up to this particular 6th point. So similarly, for all these other edges also we should do. I have carefully written this, designed this slide. I have added some animations. Please look at this. So this is my initial edge table, E0, E10, E9, E1. Edge 1 is E2, E1, E11, 2, 3, 4, 5. No, 6th one is E3, E7, E8. This is what we have done previously. And now our task is to apply these prerequisites for this particular diagram right now. So we shall see how. You can carefully see my animations. All right, we shall start. So since you can see here, E1, there is an horizontal edge. The mathematics, the prerequisite says deleted. So we got this E1. So we deleted this. And of course, we need to delete this entry as well. So E1 will now go off and E2, 11 remains. So I'll repeat. So we should do this mathematics in this polygon. One mathematics says, one prerequisite says, whenever there is an horizontal edge, you can see here E1, and which is at, can you see my mouse here, guys? Mouse pointer, can you see?
Yes, sir.
All right. So in the scan row 1, there is this E1, and E1 is here. E1 is a horizontal edge. We need to delete this. That is what we got to know from our prerequisite. So let us remove this E1. So E1 will be removed. And of course, here also we need to remove. So E2, E1, E11 will now become just E2, E11. So you can now see E2, E3. So there is this conjoint pixel, which the prerequisite says chop the lowest pixel and go up to this guy. So you can see here I have chopped. I can show it the mathematics again. So chop it, and the this is fifth one, sixth one had E3. So before chopping, E3 is at E3 is at the row called 6, right? This is fifth one, this is sixth one. So E3 starts here. If I chop this, it will now become like this. That means E3 went to which row? Seventh row. So in the seventh row, I should get my E3. I'll repeat. So this you understood now. This you understood. Now coming to this. In my sixth row, I have E3. So this
On the
is
face of it,
lower one and the upper one.
under both
And
of these
if I
versions of
chop
Galaxy,
this,
and I think the difference is so big.
so if I chop
version
this,
feels like
E3, which was at 6, which will now go to 7. So yeah, like this. Similarly, for this particular point, that is E6, E7, that is from upper hemisphere to lower hemisphere, there is this point. So you need to chop the lower hemisphere. So the row number is 10. 10th is apparently having E6. So if you chop it, it will now go to 11. That means E6 will now go to 11. So I'll repeat this. Okay, quickly. E1 deleted. So delete it, and in the H table also delete from the scan row 1. We remove it, and in the sixth row we have E2, E3. So the lower hemisphere is E2. So chop it, and the sixth one will now go to seventh one, E3, and then one more E6, E7. You can chop anything, either the lower one or the upper one. The mathematics remains same. All right, E6, E7. So chop it, it will now go to 11th. So something like this. So this is now the ultimate edge table after pre-processing. So this is how the pre-process. Yes, someone is raising the hand. Yes, tell me, Abdul. Any doubts, guys? Hello. Are you?
No,
Are
sir,
you?
no, sir. Carry on, carry on.
Yeah. So don't worry. I'll come back to this again once we're done with the mathematics. All right. So if you have any doubt, please raise your hands. I'm seeing 2 participants raise the hands. Can I see? Can I get to know your doubt? Nitin Anand, yes, boss. What's your doubt? Shall I continue?
Yes, sir.
All right. Yes, sir. So yeah, this is my updated polygon now. So we should go inside and fill it now. So the algorithm says these many things. I will come back to this slide later so that you'll understand. Now let us start with this. So this is my updated polygon. These are my before pre-processing stops, and these are my updated edge tables. You can see here there is no E1 here. Because why no E1? Because we have deleted this. And the sixth one which had E3, it has now gone to seventh one. and the 10th one, which had E6, has now gone to 11th one. So these are my updated guys. Now the algorithm starts. Now, can you guys write these codes, please? The code is okay. I'll explain the code in 1 minute. Come with now. Let us start. Let us start at y is equal to 0. Did you notice something became dark here? Here. So this is my previous slide. And in the next slide, this became dark. Means we are at this particular edge now. That is y is equal to 0. Y indicates the rows, scan rows. So in y is equal to 0, SEB means scanline bucket. So scanline bucket y is equal to 0 means I have E10 and E9. So E10 is 11, 4 minus 3 by 4. That is this one. This one. 11, 4 minus 3 by 4. And E9 is 11, 8, 3 by 8. So E9, 11, 8, 3 by 8, which came from pre-processing stuff. All right. So I'll repeat, y is equal to 0 means I have E10 and E9. E10 scanline bucket is 11, 4 minus 3 by 4, which is nothing but x min y max 1 by m. E9 is 11, 8, 3 by 8, which is also x min y max and 1 by m. Now, the next step is, once you're done with the buckets, you need to fill from this x min to this x max, this x min of E10 to this x min of E9, or else look at the first data of E10 and the first data of E9. So the first data of E10 is 11, the first data of E9 is 11. So from 11 to 11 you need to fill. So my filling goes like this. You understood now? So next is, you can see this dark line. We have removed the 14 image. Zoom is given an extra time. All right. So I'll repeat. Take edge 0. We got this, and from the first data of E10 is 11, the second data of E9 is 11. So from 11 to 11 you fill it. All right. Next one. Okay. The next point is, you need to add this particular first field and the last field. So the mathematics says x min plus 1 by m. So 11 plus of minus 3 by 4. That is 11 minus 3 by 4. It is 10 1 by 4. And 11 plus 3 by 8 is 11 3 by 8. So this is the mathematics. Once you're done with mathematics, you increment the scan line. So the dark line became like this. So y is equal to 1. So in y is equal to 1, which edges we have? We have E2, we have E11, we have E10, we have E9. So you write the E2, E11, E10, E9, the updated edges. So in the previous iteration, we have updated our edge x min plus 1 by m. This is the updated edge of E10, updated edge of E9. Can you please mute your, from your side, at your end, you muted. I'm hearing your voices. All right. So this is the updated edge of E10. This is the updated edge of E9. So E10, E9 is updated. Now, if you go to the next scan row, we have E2, E11, E10, E9, E2, E11, E10, E9, E2, E9. Copy paste from this slide. That is, this slide, E2 and E9. And for E10, E9, updated edges, you need to take it. 10 1 by 4, 11 3 by 8. So once the initial mathematics is done, next point is you need to fill it. Fill it from where to where? Look here. The first data of E2, that is 2, to the first data of 11, that is from 2 to 6. So from 2 to 6, you fill it like this. It says
Once కుదిరిన
E2
కార్ వాష్ లో ఏం
to
ఇది లేదు అలవ్
6
లేదు
of
అంత
11.
పేమెంట్లు వస్తే వాళ్ళకి
So fill
చూపించే
it.
అలవ్ లేదు
And the next filling, he says, from the first data of E10, that is 10 1 by 4 of E10 and 11 3 by 8 of E9. Perhaps 10 1 by 4 means 10.25. You can take it as 10. 11 3 by 8. You can, that is around 11.18 or whatever. You can take it as 11. So in a nutshell, 10 of E10 to 11 of E9. So 10 of E10 is this point and 11 of E9 is this point. So you fill it like this. So once filling is over, you need to write the mathematics. So can you write this code, please? The code is IFM, Initial Filling Mathematics. So first we should do the initial table. Second one is you should do filling. Third one you should do what is called as mathematics. So I'll repeat. You take this edge, the initial is this, you fill it, and then after filling you should do IFM. I is over, F is over. Now comes mathematics. Mathematics is what? X min plus 1 by m. 2 plus of minus 2 by 5 is 1 3 by 5. 6 plus 2 by 3 is 6 2 by 3. 10 1 by 4 plus of minus 3 by 4 is this. 11 3 by 8 plus 3 by 8 is this. IFM. So mathematics is over. Next is we shall increment y. That is, you can see here the green thick line is at the edge number 1. So IFM, initial fill mathematics, is over. Next one is we shall go ahead with the next row, that is 0 1 2. So 2, if I go here, the green thick line is at the 2 now. So in the second line we have E2, E11, E10, E9, all have been updated. This is the I part, initial part. So initial part is done. Next is F part, IFM. Initial is this, the updated ones. F is fill it. Fill from where to where? 1 3 by 5 of E2 to 6 2 by 3 of E11. So 3 by 5 is how much? 3 rupees by 5, guys. More than 0.5, you can take it as 2. 2 to 6.66, you can take it as 7. So 2 of E2 to 7 of E11. So fill it, something like this. And again 9.5 of E10 to 11 or 12 of E9. So you fill it. F is over, initial is over, F is over. Now comes the mathematics. So what is the mathematics? 1 3 by 5 plus of minus 2 by 5 is this. 6 2 by 3 plus 2 by 3 is this. 9.5 minus 3 by 4 is 0.75. So 9.5 minus 0.75 is 8.75. That is 8 3 by 4. 11 6 by 8 plus 3 by 8 is apparently 12 1 by 8. So IFM, initial is over, fill is over, mathematics is over. Next point, next step is increment this green thick line to the next line. So y became 3. So this is the initial. You see whether any new edge has been encountered. No new edge. So these are my new edge. These are my existing edges. So initial is done. Next is F, filling. So 1 1 by 5 of E2 to 7 1 by 3 of E11. So you start filling like this. So next one, 8.75. You can take it as 8 or 9, 9 to of E10 to 12 of E9. So F is over, I and F is over. Next is mathematics. So mathematics says 1 1 by 5 plus of minus 2 by 5 is 4 by 5. 7 1 by 3 plus 2 by 3 is this. So IFM. FM is over. So next, increment the edge, it becomes 4. In 4, do we have any new edge? No. So this is the initial. Initial is done. I is over. F starts. That is filling. And again, I am counting that as 2. Did you see this subtle animation here, guys? So this is the conjoint edge. You can consider this as twice. That's what the prerequisite says. So IF is over. Now comes the mathematics. 4 by 5 plus of minus 2 by 5 is that. And yeah, one more point is, since E11, E10, that is this E11 and E10, this is done, right? It doesn't, it ends here. So remove this, because E11 in my next edge, that is in y is equal to 5th, that is if I go to the next particular point, E11 and E10 doesn't come, so you remove this. That's the common sense. So you remove it, this is what you get. And the mathematics 2 by 5 minus 2 by 5, and yeah, that is done. And 12 turn by 8 plus 3 by 8 is done. So next you go to this, IFM is over. Next one, y is equal to 5. And we have E2 and E9. So this is the initial. So fill it. Fill from where to where? 2 by 5 is 0. 0 of E2. 0 of E2. To 12, 7 by 8. It is 13. 13 of E9. So 0 of E2 to 13 of E9. So yeah, this is how I fill. So IF is over. Now comes the mathematics. Mathematics says 2 by 5 plus of minus 2 by 5. It becomes 0. 12, 7 by 8 plus 3 by 8 becomes 13, 2 by 8. So IFM. Mathematics is over. Next is increment. Y is equal to 6. So in y is equal to 6, you can see in y is equal to 5, I have E2, E9. In y is equal to 7, I get new edges called E7 and E8. So E7, E8, you take from the before pre-processing stuff. So E2, E2 and E9, that is the first one and the last one have been updated already. But since we are encountering E7 and E8 right now, so you take these two edges from where? Do you remember we had this? Yeah, this one, before pre-processing. So E7, E8 take from this. So yeah. So filling, yeah, this is one E7, E8. So this will now become the I part, initial part. So next start filling. Filling from where to where? From 0 of E2 to 10 of E7. So that is what we did. And this is that particular edge. Count this as twice. So yeah, counting twice. So 10 of E8 to 13 of E9. So that is what we did. Again, 10 of E8 and 13 of E9. So next one. So E2 is, you are going from 6th to 7th. So E2 doesn't come here. So you remove that edge. And IF is over. Mathematics, we shall do 9 1 by half plus of minus half is this. 12 plus 2 is 14. Sorry, 10 plus 2 is 12. 13 2 by 8 plus 3 by 8 is this. IFM, mathematics is over. Next is increment the edge. Now look at this point. This edge is interesting. So I was at y is equal to 6, and now I'll go to E7. The moment I go to E7, I have a new guys, E3, E4, E5. So E7, E8, E9 we have. So E3, E4, E5 we have. So add these edges from the pre-processing edge, before pre-processing. So all these will now become y is equal to 7. Add these edges. So these are my initial stuff. So next comes F, filling. So fill from where to where? 1 by 3 is apparently 0. 0 of E3 to 4 of E4. So 0 to 4. Again, 4 of E5 to 9.5 of E7. So here is how 9.5 means you can take it as 10. 12 of E8 to 13, this of E9. So this is how you fill it. So IF is over. Next comes mathematics. So 1 by 3 plus of 1 by 3, 2 by 3. 4 plus of minus 2 by 5 is, do the mathematics. 4 plus 0, 4. 9 and a half minus half is 9. 12 plus 2, 14. This plus this, whatever. Just keep on doing this. IFM. Remember that code called IFM. So initial, fill, and mathematics. So this is how you can fill any polygon. This is what general scanline filling algorithm does. Now I'll come to this particular this algorithm. Start with the smallest empty, that is y is equal to 0. Initialize, and while current y becomes from 0 to 13, merge this to this, sort on x minimum, fill pixels between rounded pairs of x values, remove edges where scanline bucket whose y top is equal to current y, that is, we'll no more the edge. Increment x min by 1 by m. That's what we did. That's the mathematics. X min plus 1 by m. That is the step number D. Increment, that is increment y is equal to y. So I hope you understood. Yes or no?
Yes, sir.
Yes, sir.
So
Yes, sir.
a quick in 2 minutes we will conclude this. So this is the mathematics x min y max. This is the not the mathematics. This is the scanline bucket. That is x min y max 1 by m, and this is my polygon. These are my edges. These are my before pre-processing stuff, x min y max 1 by m, and these are my prerequisites. So a conjoined guy, count it as twice, and the lower one to upper one, or the upper one to lower one, chop it. So the next one is whenever you have a horizontal edge, delete it. So you take the polygon, you have the initial stuff, and apply the prerequisites first. So this is how my prerequisites done. Will how happen. And once the prerequisites are done, now start applying the algorithm. Take the initial stuff and go by y is equal to 0 till you reach this 30. So write all the edges, and here is where you need to apply that IFM concept, initial fill mathematics. So this is the initial fillet mathematics, initial fillet mathematics. So just goes on till till you fill all this. So finally you will get this. So I hope you enjoyed the session. That's it for today, and tomorrow we'll continue the other topics. Thanks for your time, and I really
Thank
appreciate
you,
it.
sir.
Thank you, sir.
Can you please
Thank you, sir.
drop your feedback?
Thank you, sir.
That would really help me either in WhatsApp or I don't know, so that I'll improve. If there is any trouble or whatever. Thank you, boss. Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.